So a few more properties of logs I want to talk through. Now, for these three, I want you to remember that logs are really a way of finding an exponent. So exponent rules are really going to come into play when we're talking about these log properties. All right, so the first one says log base A of u times v. So if we have a product inside our argument. Remember when we're talking about exponents that are being multiplied, um, or things that have exponents that are being multiplied, I should say. So something like x to the second times x to the third, we end up adding those exponents together, right? So this is basically the same thing. We are multiplying within our argument. What we're going to do is turn this into an addition problem. So we turn it into two separate logs. So each piece of the argument will get its own log. So I'm going to say log base A of u, log base A of v, and these logs will be added together, just like the exponent rule states. So multiplication in an argument turns into an addition of logs, but each piece of the argument gets its own log. Okay, so it's not like log base A of u plus v. It's log base A of u plus log base A of v. All right, so second one, now let's think about division. So let's, again, relate this back to exponents. If I have something like x to the sixth over x squared, hopefully you remember that we would subtract those exponents and get 6 minus 2, keep the base of 4. Same thing with our logs. If we are dividing our argument, let's split this up. So each piece of the argument gets its own log. Okay, log base A of u, log base A of v, but we're going to subtract the two logs. Okay, so a fraction within our argument turns into a subtraction of the logs. And again, it's just like the exponent rule. The last one is a little harder to explain in terms of why it happens, and I can try my best. If you guys are curious, let me know. But basically the rule for if you have an exponent on an argument, okay, what we're going to be able to do is pull that out front and it turns into a multiplication problem. And actually, I just thought of a way to explain it. So let's think about this. If I have like x to the third, but it's being raised to the fifth power, do you remember what you do with exponents there? You multiply them. So anytime you have a power that's already on top of another power, we'd multiply. Okay, here's our exponent. We're going to turn it into a multiplication with the rest of the log. So exponents come down front and become coefficients. So it would be n times log base A of u. Okay, exponents down front, or all of these can be reversed. If you see a coefficient down front, that means it used to be an exponent on the argument, right? So you can undo it. If you see two logs being subtracted, that means it used to be a single log where those arguments were being divided. If you see two logs being added, again, that means it used to be a single log with those two arguments being multiplied. So we will be using these properties backwards and forwards as we go to simplify and solve log problems.